In this video, we'll be approximating the slope of a graph, and the graphs we have been given will have a tangent line drawn for us. I already alluded to the fact that the tangent line has exactly the same slope as the graph at the point of tangency, so we can use the graph paper here to help us find the slope of this tangent line. And that will tell us what the slope of the curve is there at that point. So from this point to the next point where I see a point of intersection between horizontal and vertical grid lines, it looks like I went right one, up one. That seems consistent that I also went right two, up two. So it appears that the slope here is 1 over 1. Rise over run is 1. Here, the tangent line appears to be horizontal with no rise, so the slope will be 0. Let's go ahead now and look at one more for this particular video. That will be number 13, and I'm going to clear all this out and grab number 13 here. So that you can see the problem and the picture. To copy and paste. I'm going to make this pretty big so you can see those grid lines as best as possible because it was a small part of the graph. So the graph represents the revenue in millions of dollars, don't miss that, for Under Armour shirts here that they've pictured from the year 2008, which corresponds to T = 8, through 2013, which corresponds to T = 13. T represents the year with T = 8 corresponding to 2008. So T = 0 corresponds to the year 2000 is what that tells me. This little almost lightning bolt thing in the graph means that this part here of the graph is deleted, that it's not to scale, that one tick mark here from 8 to 9 is not the same as the tick mark here that's from 0 to 8. So they just took out a part of the graph that's not interesting because it doesn't exist. Be careful about doing that because that actually causes a distortion in people trying to draw conclusions and things. Sometimes it can stretch or whatever your graph, make it it makes it appear that it's doing things that it's not actually doing. So you need to be really careful when doing this. It's necessary sometimes, and you need to put that mark there when you do so that people know that you have eliminated a portion of that axis. All right, estimate and interpret the slopes of the graph for the years 2009 and 2011. So at 2009 right here, we're going to try and draw a tangent line to the best of our ability here. And let's see if I can do that. And this is a really tough problem. I'm just telling you, I know that you get assigned a problem like this, even if you're using WebAssign. And I think it's even harder in WebAssign than it is in the book because you don't have anything. It's really hard to look at the graph paper that they do provide in WebAssign, that these lines are really lightly colored and hard to see. Again, I think if this would quit moving, it would be awesome. This is the only problem with this. All right, so there we go. And I'm going to take a look at that. That's my best representation of my tangent line. at 9, and it looks like it's going to go through 9 and maybe that's about 800, I think. So it looks like it's going through the 0.9 800, and then it looks like this probably goes through 10, and see, I'm a little off. I'm not touching the line there. So I think this probably goes through 10, 1000. So let me just guess that that happens. So 10 and then 1000. So that's going to be 200 over 1, but that 1 is that 1 is 1 year, but this 200 is really 200 million. So don't forget that. So, and I'm pretty close, and it's really hard. So I'm just going to give you the answers that they give in the textbook, that M in this first point at x equals 9, M is approximately 188. And again, that's millions of dollars per year. So I said it's about 200, and it doesn't let you just get close with that with WebAssign for some reason. You have to get really accurate. So zoom in as far as you can. Try and find somewhere where it crosses exactly. This next one is a little bit better. If we could find where, what was the next piece? When in 2011 is the next place that we want, which is right up here. And I'm going to tell you that when x equals 11, it's going to be a change of about $375 million per year. So we can zoom in here and see that we went up this much, and then 1 year, this difference here is about this rise right here. If we would make a slope triangle, because the slope is just about right there. This side is 1, and this side is just about 375. So we get about $375 million per year. That is probably one of the most challenging problems that you're going to have to do in this entire section. And because you don't have any formula and you just have to eyeball it, and they want you to get really accurate results. So get a magnifying glass if you need to, something that you can zoom in with the computer, do the best that you can. Don't round anything. If you can help it, try and get right in there and look at that point and say, okay, at 9, that point is at, and give your very best estimate at where that is. It's hard where they don't give you a lot of tick marks in between, and they're going by 500s. So every 20% there is another 100, but do your best. All right, that's it for this video. We'll come back next time and we will continue this discussion on tangent lines and slopes and we will start finding the slope of a graph at a particular point by using the limit definition of the derivative to find the slope. So I'll see you back here for that video next time.